Okay, so let's go back to the first exam. And just kind of talk about some of the ones that were kind of commonly missed. So it's really interesting sometimes to look at what's commonly missed to see if there's like a theme. Sometimes there is, and sometimes there is not. It's all random. Okay, so the first one that seemed to throw people a little bit, and I don't think it was because they didn't know how to do it. I think it was they didn't know what to do with their answer to get it to match up to one of the choices. And for most of the questions, there's more than one version, so I'm not going to do all of the versions because they're all pretty similar. Like some of the numbers are just changed or something like that. Okay, so this was number, I think it's number 2. Yeah. So this is where Dominique invests $12,000 in Steam at 20% compounded continuously. How many years will it take for her investment to reach 48,000? So for these compound interest problems, there were two formulas to choose from. And the one that we're going for is A equals P times E to the RT. And there's a reason why we're choosing this one, and it's because it was compounded continuously. If it was any other type, like if it was compounded monthly or yearly, then you would use the other formula. Okay, so our final amount is the A, so that would be your 48,000. The principal is how much you invest, so that would be 12,000. The E stays as E. Your R is your interest rate. So 20% would be 0.2 or 0.20, either way. And we're looking for the number of years. So we don't know the T value. So that's what we're trying to solve for. So how would I solve this?
You would divide both sides by 12,000.
Mm-hmm. Yeah, try to get the E part by itself. So yeah, divide that 12,000 over. So that would just give you 4 over on the left side. Then E to the 0.20t. So we need to do something that would get that t out of the exponent. So we have to eliminate the e. So what gets rid of an e?
ln.
ln. So we're going to take the natural log of both sides. So we have ln of 4 is equal to 0.20 or 0.2 t. And now you just got to divide. To get the t by itself. But when you looked at your answer choices, that wasn't one of the selections. So if it's not one of your selections, you gotta you don't want to automatically choose none of them because there might be something that you can do, especially with logs and their properties. So like ln of 4, we can do something with that because the 4 can be rewritten as 2 squared. And with log properties, what are you allowed to do with that little exponent?
Oh, you're allowed to put it out in the front.
Yeah, any exponent like this, you can pull it down to the front. So that would be 2 ln of 2 divided by 0.2. And now you can simplify, excuse me, you can take a 2 out of the 2 that we just pulled down in the 0.2. So that's ln of 2 over 0.1. And that was one of the choices. And it shuffles them around, so I don't know what choice it was for you, if it was A, B, C, or D, or E, because it's different for every test. So just whatever that choice was, that's the one that you wanted to pick. So logs in particular, you can't forget that they always have those properties with them. So if your answer isn't showing up, look at what you have and go, is there a way to rewrite this so that it is one of the choices? Okay, any questions on this one? All right, I'm going to skip around a little bit to one that kind of relates to it because it was another log property. So this one was number 11. And it was, which of the following expressions are equivalent to like ln of 4 plus ln of x squared. And then it gave you 3 options, and which of the options, is equivalent to this. So with log properties, kind of right off the bat, what does this plus sign tell you that you can do?
Multiply them?
Yep, you have to multiply them together. If it was subtracted, that would turn into
division.
So we know that one of the equivalent expressions was when you just multiply them together. So that one was good. So ln of 4x squared. But then we can start doing some other stuff to it, because kind of like what we just did up in the previous problem. You can pull exponents down. So the square, it'd be nice if we could pull it down, but we can't do it just yet because you can't do it on individual terms. So let's play around with it a little bit. And we can make the 4 a 2 squared. Now everything is really squared in there. So it's really like having 2x and the whole thing is being squared. And now you can pull that exponent down and get 2 ln of 2x. So that was the other one. So that was choices 1 and 3. Oops, sorry, 2 and 3. Okay, let me do the other one just because it is a little bit different, the other version. So it's ln of 6 minus ln of x squared. So the division would apply. So the 6 over x squared. And out of the options, that's the only one we can really do. So that one was just choice number 1. All right, let's see. Any questions on either of those?
Professor?
Yep.
Yeah. Can we go back to question 8 on the same one, please?
That was actually going to be my next one. I have a list that I wanted to get through, and then we can take questions that you guys might have too. But I wanted to hit some of the questions that just people missed a lot and get those done first.
Okay, cool.
Okay, but number 8 was one of those. So that one was like, what is the smallest degree possible for the given graph? Wait, is that it? Yeah. And there were 3 different ones, but the process is the same for all 3 of them. So let's try this one. So I had, one of them had a bounce over here, a slide in the middle on the origin, and then another bounce over there. So a bounce, a slide, and a bounce. So this is where you have to know something about the degrees or the multiplicity when something bounces versus when something slides. So if the intercept is a bounce, what kind of multiplicity does it have? Is it even or is it odd?
Even.
It's even. So that means for that particular intercept, that could have been a square, could have been a 4th power, it could have been a 10th power. We don't know exactly, but it wants to know what is the smallest. So the smallest even that would cause a bounce is going to be a 2. And same thing for over here. Now for the slide, that multiplicity is going to have to be odd. But it can't be like a 1, because then it wouldn't be a slide. It would just go kind of straight through it. So the smallest odd that would cause a slide would be 3. So you've got a multiplicity of 2, 3, and 2. So if you add those up, that would give you a total of 7. And that is the smallest degree possible. It could be larger than that, depending, if this was a 4th power, an 8th power, and an 11th power. But we can definitely know the smallest degree possible. So a bounce would have a 2, a slide would have a 3. Oops. So if we did this one, what would be the smallest degree possible for that one? So you got a bounce, a slide, and a slide.
8.
8. Because that's 2. That would be 3 and 3. So your smallest degree is 8.
So it's an absolute value on that negative side?
Oh, well, this is talking about the multiplicity, not the actual intercept itself.
Okay.
So this would be like x plus a squared. So the multiplicity is talking about the power,
okay,
not the actual intercept itself. All right, any other questions on number 8?
No.
All right. All right, one of the other ones people missed a lot, and I think it was mainly because they just didn't see something, or they just kind of did it way too fast. It was a multiple choice, or sorry, fill in the blank. It was part C on number 25. And it was like ln of f inverse of e squared. And I wanted you to evaluate that. And I think what happened is most people just did the function part and then they just forgot that there was other stuff in there. So typically, like, what happens when you have a function and an inverse like plugged into each other?
They like cancel out and it's just.
Yeah, they cancel out and then you're left with everything else. So what I saw a lot of people put is they just did the e squared, but they forgot that there was an ln in there. So you're really left with ln of e squared, and that'll reduce even further. So your ln and your e cancel off, and so you're just left with a 2. So again, something that's like, I know people know how to do it. It was just something in there got lost or just kind of glossed over.
What would ln of 1 be?
0.
Okay.
Talking about just like ln of 1 just by itself.
Yeah.
Like that. Yeah, that's always 0.
Well, that makes sense because, yeah. E to the 0 would be 1.
Well, let's back that up. Why does it make sense?
Because the ln is like the log to like the little e, and then e to the 0 would be 1.
Yeah. So and it doesn't matter like what the logarithm is. Like if it's log base 3 of 1, that's always going to be 0. So in any logarithm, if you have a 1 in there, it's always going to equal 0 regardless of the base. Because 3 to the 0 is always going to be 1. Because remember, a logarithm is just an exponent. It's the exponent of the base that gives you this number here. So if it's a 1 in there, then the exponent has to be a 0. Okay. All right. So you guys think you're pretty good with these, or okay with them, at least for now? Okay. Let's see. Do you have any other questions from exam 1 that you wanted to see that you're just like, how did we do this?
There's like a study guide question that says find the inverse of f of x and then equals x over x plus 8.
X equals
X over x plus 8. And you're supposed to find the inverse.
8. Okay. So first thing, just change the y, or f of x into a y. And then what do you do next? This next step would be a universal step, regardless as to what equation you have.
The x's for y's and the y's for x's.
Yeah. So if it was quadratic, rational, trig function, logarithm, exponential, like you're always going to switch the x's and the y's around. And then once you do, then your goal is to solve for y, and that's where all of the equations will start to differ from each other. Because solving a quadratic equation is going to be different than solving this equation, which is different from a trig equation. So it just depends on what type you have, and that'll tell you how to proceed. So for this one, how could we continue?
I would cross multiply.
Mm-hmm.
I don't know how to go.
Yeah, just take that denominator, multiply it over to the x. Okay, and then this is where you have to remember what you're solving for. And in this case, you're solving for y. Mm-hmm. So we can bring the xy over to the right.
Oh, and then you take the y out.
Yeah. Oops. So it's 1 minus x in there. And then you just divide by your 1 minus x. And that would be your inverse function. There's another answer you could give to, and it just depends on what you do here. Some people would move the xy over to the right. Others will take the y and move it over to the left and put the x on the right, which is totally fine. And what that would do is pretty much everything would be in the same place, but it would just be negative. So you would have had like negative 8x over x minus 1. And either answer is totally fine. They're both equivalent. So both are acceptable. Okay. Anything else from exam 1?
Oh, how do you graph? Like, I kind of forgot how to graph. Like, I have an example. Y equals 5 minus, like, square root of 16 minus x.
Y equals 5
minus the square root of 16 minus x.
Root 16 minus x, like that? More or less?
Yeah.
Okay. So the square root graphs, these are the ones that start at a point and then they'll shoot off in some direction. So it's either going to go up and right, down and right, up and left, or down and left. And it all just depends, like for which one of these it is. It depends on the sign on in front of the radical and then the sign in front of the x. So if the radical has a negative sitting in front of it, that means it's going to go down. So it can't be the ones going up. So it's either this one or this one. And because the x is negative, that means it's going to go to the left. So it can't be that one. So this is the shape that you're going to go for. So normally the graph would start at 0, 0, but it's been shifted around on the y's and also on the x's. So if you have a number that's totally off on its own, like it's not attached to an x, that's telling you like how far up or down it's being shifted. So since it's a positive 5, it's going up by 5. And then when there's stuff inside with the x being added or subtracted, that's going to shift it left or right. And to figure out what that is, just solve for whatever makes it equal to 0. And you can do it in your head, or you can write it out. And it's just the inside. You're not worrying about the radical, the 5, the negative, anything else, just whatever's inside of there. Set it to 0. This one you can swing the x over. So x is 16. So since it's a positive 16, is that going to go left or right?
Right.
Yeah. 16 to the right, up by 5. And you can just label the point. You don't have to put in like 16 little dash marks in there. You can, but it's faster if you just label it. And we know it's going to go like this, but we have to be accurate in what we draw because you're also going to have to do the intercepts. So how do you find, let's say, a y-intercept?
The y-intercept, you plug 0 in for x.
Yeah. All right, so let's do some quick math. 16 minus 0 is
16.
Square root of 16.
4.
5 minus 4.
1.
1. So your y-intercept is positive, so it's hitting the y-axis about there. So we just need to draw it and have it hit the y-axis at a positive 1. And these are, you know, none of your graphs really have to be to scale. They just have to be accurate. Like if it's a positive 1, don't put it down there, because now that's on the negative y's. So you just got to make sure wherever you put the 1 that it's on the positive side, but lower than that point. All right, now how do you find an x-intercept?
You plug 0 in for the y.
Mm-hmm. Yeah.